real numbers. We're going to go ahead and divide numbers into different sets. We're going to be using a Venn diagram. Now with Venn diagrams, the parts of circles that overlap is what they have in common. Here, our circles are going to be inside of each other. So that means the smaller set is a part of the larger set. So we're going to start with the smallest set of numbers. And the smallest set of numbers are the natural, or the counting numbers. Now understand, when I say smallest set, I don't mean they have small numbers inside of them, but they have the least amount of numbers. Natural numbers, or counting numbers, start at 1, and then go 2, 3, 4, 5, so on, all the way up, up, up. And you know there's always one more number that you can add. So natural numbers is actually a pretty big set of numbers, but it is still the smallest set overall. The next set of numbers is whole numbers. And there's only one number different between natural and whole numbers. Now I know it doesn't look like that from the circles, but the only number that's a whole number that is not a natural number is the number 0. So 0, 1, 2, 3, 4, so on. The next set of numbers is twice as big as whole numbers. The next set is integers. Integers are whole numbers and their opposites. That's why it's twice as big, minus 1, because 0 doesn't have an opposite. So it's negative 3, negative 2, negative 1, 0, 1, 2, 3, and so on in both directions. So all natural numbers are whole, all whole numbers are integers, and then all integers fall under the category of rational. And rational numbers are fractions and decimals that are terminating or repeating. If you use the word rational to describe a person, you know that person can think things through, they put thought into what they're doing. Well, the opposite of rational then would be irrational. And notice there's a divider between rational and irrational numbers. These numbers are not the same thing. They're not part of the same set. Well, irrational would be crazy. So you could think of irrational as crazy numbers. So some crazy numbers that you know is pi. Pi is a decimal that goes on and on and on and on forever. Other irrational numbers are the square root of non-perfect squares. If you take the square root of 50, it might look like it terminates on the calculator screen, but really it only looks like that because the calculator can only hold so many numbers. This decimal does go on and on and on without a pattern. So all of these numbers, rational and irrational, are considered real numbers. Now over here, we have the opposite of real. Opposite of real numbers are imaginary numbers. And imaginary numbers are the square root of negative radicands. And it doesn't matter whether that radicand is a perfect square or not. You can't take the square root of a negative number. So remember, square root is trying to find what number times itself gives you that number. Well, to get a negative, you can only do a negative times a positive, and those numbers are not the same. All right, so let's go ahead and classify some numbers. So what we want to do is write all names that apply to each number, so a third. And it is helpful to kind of have that Venn diagram nearby. Because remember, once you find the smallest set that the number belongs inside, it belongs in everything on the outside of it. So 1/3. 1/3 is not a natural or a counting number. It is not a whole number, so it is not an integer. But it is a rational number because it is a fraction and can be a repeating decimal. So it is rational, and it is also real. 6. Okay, well, 6 is a natural or a counting number. That means it is a whole number, it is an integer, it is rational, and it is real. Negative square root of 36. Well, the square root of 36 is 6, and the negative comes out in front, so negative 6. Negative 6 is not a natural or a counting number, so it is not a whole number. But it is an integer because it's the opposite of a whole number. So it's an integer, and therefore it is rational, and it is real. Square root of 10. Well, square root of 10 is a non-perfect square. So that means it is irrational and real. So remember, irrational numbers still fall under the real number set. 0 over 7. Well, that means 7 into 0. What number times 7 would give you 0? And that number is 0. So 0 is not a natural number, but it is whole integer, rational, and real. And the last one, square root of negative 25. Well, 25 is a perfect square, it comes out as a 5, but the negative, this would come out as 5i. I for being imaginary. So this is an imaginary number.